Radhe Radhe, hi everyone, hi guys. So if you're new to this channel, I'll just let you know that you can subscribe my channel. Press the bell icon. Okay, that's too little bit of uh, legacy code based type of thing. So anyway, so yeah, please do subscribe my channel, and I actually post mostly Leetcode, post contest discussions, or sometimes even code forces and code chef and everything else. So that's a little bit about myself. So that's my introduction before starting the video. So in this video, we are going to discuss weekly contest 490, where I will be discussing the first, second, third, and fourth questions. All of them are solved. If you want to know, yeah, it's an AK already. So okay, that's it. Let's start with the first question. Okay, so the first question is find the score difference in a game. You're given an integer array nums where nums of I represents the points scored in the ith game. There are exactly two players. Initially, the first player is active and the second player is inactive. So the following rules apply sequentially for each game I. If nums of I is odd, then the active and inactive players swap roles. That is, the inactive player becomes active and the active player becomes inactive. In every sixth game, no matter what is the score, there will be another operation that will be taking place. That is, the active and inactive players will swap also. The active player plays the ith game and gains nums of I points. So you have to return the score difference defined as the first player's total score minus the second player's total score. Very simple. I'll just take an example. 1, 2, 3. The first player is active, but since it is 1, so the second player becomes active now. So second player scores 1 point. Now it is 2, so it's an even number. So there is no change in there is no swaps. So the second player scores 2 also. So 2 plus 1, that is 3. Now there is a 3, that is an odd number. So now the first player becomes active and the second player becomes inactive. So the first player gets 3 points. So the difference between the first, that is 3, minus 3, that is 0. Okay, so that is the answer basically. Let's take another example for better understanding. Let's take this example and try to understand what is happening. Leetcode does this thing. Leetcode uses copyright. Okay, so let's say initially there are two players, player 1 and player 2. Okay, we don't know who is active. Yeah, we do know initially who is active. We know initially 1 is active. So this is a 2, so it's an even number. No issues. 1 will get 2 and 1 will remain active. It's a 4, again an even number. So 1 will get 4 also. Now there is again a 2. Okay, 1 will get 2 again. Now there is a 1. Okay, so that's an odd. That means now 2 becomes active. Okay, 1 becomes inactive. So 2 will get 1 point. Again a 2. That means an even number. So no swap. So 2 will get 2 points again. Now there is a 1. So there is a swap, right? Because it's odd. So 1 gets a point. But nope. We are at the 6th position. 1, 2, 3, 4, 5, 6. So if you remember, there was a rule. The second rule was in every 6th game, the active and inactive players switch. So again, this becomes inactive and this becomes active, and thus this person gets 1. So if we add it up, it becomes 4, 5, 7, 8, 8, and this one 2, 3, 4. So player 1 minus player 2 is it is minus it is 4, right? Okay. And if the opposite thing would have happened, then it would be minus 4. Okay, because it's not telling us to get the absolute value. So I think that is pretty much everything. We can move on to the code. It's very simple. Player 1 has score of 0, player 2 has score of 0. Active is 0, that means player 1. We traverse through all the nums. If it is odd, then there's a swap. If it is it is a sixth game or a multiple of 6, I plus 1 is a multiple of 6, then also it swaps. And if count is equal, active is equal to 0, that means player 1 will get the score, otherwise player 2 will get the score. And at the end, you can simply return P1 minus P2, that is a score of player 1 minus score of player 2. Very simple, very simple. No, nothing like too complex stuff. Okay. Anyways, I don't know if anyone is watching my video right now or not. If you are watching my video, do give it a thumbs up and please do comment on please do write something on the chat so that I know that I'm audible and visible as well. I mean, not visible, but I'm audible. Yeah, I used to stream a lot using live cam, but I think that it is too much of a setup. Okay, no issues. Let's let people come slowly. We'll wait for them. Till then, we can move on to the next question. The second question is check digitorial permutation. You're given an integer n. A number is called digitorial if the sum of the factorials or its digit is equal to the number itself. Okay. Determine whether a permutation of n forms a digitorial number or not. Return true if such a permutation exists, otherwise return false. Which means, what is a digitorial? A digitorial means that, let's say 145. 145 is a digitorial, I know from the example. Oh, it's too big. So 145, why is it digitorial? Because factorial of 1 is 1. Factorial of 4 is 2, 3, 4, 24. And factorial of 5 is, I think it's 120, if I'm not wrong. Okay. Now if I add all of them together, it becomes 145. That is the number itself. So 145 is a digitorial number. Now, since 145 is a digitorial number, 541 is also a valid number because 541 is a permutation of this 145. So this is also valid. So for 541 also the sum will be same, but the sum will be equal to 145. So in that case, we need to check if it is a permutation or not, if both the numbers are permutation or not. That is, we will find the sum of factorials of all the digits in the number, and whatever the sum is and whatever the number initially was, we are going to check if it's a valid permutation or not. Okay, very simple, no rocket science stuff. Okay, let's look into the solution quickly. Since I know that the factorial is of digits, so I can store all the digits factorial in one array. Okay, where 0 is 1, and then for every factorial is equal to factorial of I minus 1 into the I, right? That we know. That's very simple. So the sum of factorial is initially 0. Then we have a temp. So for all the digits in the n, we are going to sum the factorial, sum plus equal to factorial of 10 mod 10. And then we are going to return if sum and n is a permutation, that is permute. Okay, what does permute do? Permute takes a frequency array of size 10, that is all the digits. For all the numbers in A, it's going to do plus plus, and for all the numbers in B, it is going to do minus minus. So if the frequency of all the numbers in A and B matches, then the frequency of all the digits will be 0, because the number of times it gets added, the number of times it gets minus, I mean subtracted. So if it is 0, so if it is not 0 at any case, so we can say that it's not a valid permutation. And if it is a valid permutation, it will not get stuck at this position only. It will not go through this if condition only. The controller will fall off and then it will return a true. Okay, as simple as that. As simple. I see there are very less people today, I guess. Okay, I do get it. Sunday morning, I do get it. Anyways, no issues, man. I'll just check my audio quality. I am assuming that I'm properly audible. Okay, I'm audible. So it's like of no use to keep the chat section. Still, I'll keep it. It was actually a little bit demotivating for a content creator like to come live and to find out that not much people are watching my video. So, anyways, no issues, man. So let's move on to the third question: maximum bitwise or after arrangement. You're given two binary strings s and t, each of length n. You may rearrange the characters t in any order, but s remains unchanged. Return a binary string of length n, represent the maximum integer value obtainable by taking the bitwise OR of s and rearrange t. Okay, it means that you're given a binary string s, you're given a binary string t. The s looks more like a r. Okay, now it's a s. So s and t, right? S you can't rearrange, but T you can rearrange. Okay, now since you can rearrange, again the concept of the permutation, that is, I'm going to have a frequency. So for the frequency, I can have a frequency of 0 and frequency of 1, since this is a 2 bit, right? I mean, there are two possibilities, right, of every bit, 0 and 1. So I can find the frequency of 0 and the frequency of 1. Okay. Now I have to XOR it up with S, right? So what I will do is, see, if I want to maximize the result, so I have to go from left to right. Okay. And the leftmost element which I can make 1, I will try to make it 1. Okay. And if it is not possible, then I have to go with 0 only. But if I can make it 1, I will make it 1. Okay. That is the main logic behind it. So S is fixed, but T is not fixed. So I can have the 0 1. Now let's say the S starts with 1 1 0 1 0 0 1. Let's say it's like this. So if I want to maximize the XOR, so I have to take the opposite element, right? I have to take the 0. So if I'll check if T has a count of 0 greater than 0 or not. That is, there is some 0 in it or not. If there is some 0, I will put the 0 over here and the XOR will become 1 for that position, right? Now I will reduce the count of 0 by 1. Okay, it gets reduced by 1. Minus minus. Now there is another one. So we do the same thing. Okay, but let's say now we find out that, okay, there are no zeros left, so we can't do anything. So we have to by default take a frequency from 1, and now since it is from 1, it will become 0. Okay, then again there is a 0. Now obviously 0, that means there is a 1 already that we already have. So we can take the frequency from 1, and now it becomes 1. Okay, as simple as that. I'll walk you through the code quickly. I'm taking the length of S and T, which is same. I'm taking the character array so that it will be better for me to compute. Okay, I'm taking the frequency of 1 in 1 and 0 in 0. So I'm going through all the elements in T. If it is 1, 1 plus plus. If it is 0, 0 plus plus. So I know the frequency of 1 and 0. Then I'm going to again traverse through S, and I find that if S is having 1 at the current position, so what is our greedy approach to do? Our greedy approach is to check if we can have a 0 from T over here or not. If we can have a 0 from T over here, then then the answer will become 1 at that position, and the frequency of 0 gets reduced by 1. Otherwise we will be forced to use a 1, thus it will become 0 and 1 minus minus. Okay, and if it is not 1, then the opposite thing happens, that instead of taking 0, we are now going to check for 1, and 1 minus minus, and 0 0 minus minus. Okay, the opposite thing. And at the end we can return the new string ch, that is, we can return the character array as a string. Okay, since not much people are active, I don't get the motivation. Okay, I just told you guys that I don't get the motivation to like even live stream if not much people are active. But I can't blame you guys. So it's a little bit demotivating. So either I think like you guys are having a good time, maybe you guys are not much interested in the solving and stuff. But yeah, if you're new to this channel, I'll just tell you that do subscribe my channel and let you share my videos with your friends who do Leetcode up solving of contests. Okay, because I usually post a lot of videos on up solving of contests. So okay, so this is the last question that we're going to discuss. The question 4: count sequences to k. You're given an integer array nums and an integer k. Start with an initial value val equal to 1 and process nums from left to right. At each index I, you must choose exactly one of the following actions. You either multiply val by nums of I, or divide val by nums of I, or leave val unchanged. After processing all elements, val is considered equal to k only if its rational final value equals k. Okay, why do we say rational final value? Because it is like, see, division is rational exact, that is not integer division. For example, 2 by 4 is not equal to 0, it's equal to half 1 by 2. Okay, so it is basically like, it is like shouting out to us that we can't calculate val. Okay, it is not val, it is numerator and denominator thing. Okay, so if you're multiplying, multiply with the numerator. If you're dividing, divide with the denominator. Multiply with the denominator. Okay, that is what it is shouting out to us. So 2, 3, 2, and 6. Okay, now see, before going into the question, let's understand the constants. The constant says that the length of the nums is 19. Okay, not too big. Recursion is a possible thing. And nums of I is 6. So which means that, okay, not too much also. Okay, not too much. So that means that we don't have to like compute huge values. Okay. So that even like what, like if it is 19 also and find out that nums of I is somewhat more than 6, then it will have a long overflow. Okay, not integer overflow. It will have the long overflow also, because 6 to the power 19 is already on the peak of maximum long. Okay, if it goes beyond that, it will become more. Okay, so we can't do that. So now since we know this, so one thing that will come to your mind is that we can go like state by state. That is, let's say you're having an array and you're going to recurse through all the elements, and for every element you either take it or multiply it to the numerator or multiply it to the denominator, right? You multiply to the numerator when you're multiplying. You multiply to the denominator when you are dividing. Okay, clear? So that is what will come to your mind. But there are three possible states, right? You either leave it unchanged, you multiply, you divide. That is 3 to the power 19. Do you have any idea what 3 to the power 19 is? It is a huge number. Okay, it is a huge number and we can't do that. But what if I tell you that we are going to do the same thing, the same logic that I'm telling you, we are going to do the same logic. But instead of going 3 to the power 19, we can divide it into two parts. Okay, this 19 we can divide into two parts. One will be 9 and one will be 10, right? That makes it 3 to the power 9, 3 to the power 9, comma, 3 to the power 10, the maximum of both of them. That is 3 to the power 10 only, right? Of 3 to the power 10. Now 3 to the power 10 is, okay, well within our limits, not too much. Okay, not too much. Now how can we do that without even changing the logic, right? Okay, let me tell you. Since for every state I can memorize their values, but how would I memorize the values? Okay, so in order to memorize the values, we can have a memo map. Okay, memo map. What is the map going to store? The map is going to store. The map is going to store. The map will a nested map. Okay, if we query at the map num, that is a numerator, we will get another map. And in that map, if we query the map's denominator, then we'll get the count of states, sorry, the count of states which is having numerator as num and denominator as 10. Okay, a little bit complex data structure you call it, but it's going to look like this: long, map of long, comma, integer. Okay, so now we know the count, right? We know the count, we know the num, we know the den, we know everything, right? At this point we know everything. Now how would you do that? Okay, earlier it was quite easy, but now if we look at this, so num and den, so let's say num is, guys, just wait a minute. Okay, just wait a minute. Okay, so as I was telling you that it is going to be like, let's say num is let's say 10. Okay, and denominator, let's say it is 55. Okay, so we can't keep it like 10 and 55, because 10 by 55 is nothing but 2 by 11, right? So we have to find the GCD out of them and divide numerator and denominator by the GCD to get the denominator. So to get the numerator and denominator, right? So we have to always go on doing this step. Okay? So we have to take the GCD and GCD out of them. So we get the most optimized rational division, rational fractions out of it. Now there are various ways to save this fraction. I prefer this map, okay, because like I am not much focused on optimization or more beautiful structure of the code, structure of the code. I'm not much interested into that. So that is what I've done. Okay. Now the most important thing, like how can we divide it into two parts? See, we can take a map, and for the first part, that is the 9, the length 9, we can store all the states. Okay. And now when we are going for the 10, the next 10 rather, now we are not going to store anything. We are going to compute it. Okay. And when we are computing it, we are going to check, instead of checking that if the value is equal to k or not, we are going to check what is the numerator that is needed. Let's say the current numerator is cnum and the current denominator is cden. Okay. So what is the needed numerator? Let's say need num. I know my handwriting is not that good. It looks like some I am just scribbling stuff. So it can be need num or need den, right? So what is need num? Need num is nothing but cden into k, and need den is nothing but cnum. Because if we multiply them, then cden and cden gets cancelled out, cnum and cnum gets cancelled out, only remaining thing is k. Okay, so that is the main thing. Need num is cden into k, and need den is cnum into cnum. Okay. Now let's look into the code. It will be give you a better understanding of what I'm trying to say. See, I'm taking the numerator as 1 initially, denominator as 1 initially, because it is 1. Value is 1. We have been said that. Answer is initially 0 because we are not going to do anything. Map is new hash map. Now fun. One function, fun, is for the first half, and fun1 is for the second half. Okay, just to know. Now let's say what we are doing in the fun. What we are doing in the fun is, let's first of all not analyze this part. Okay, we can analyze this part later. What we are doing over here, we are either doing nothing, because that was also a condition that we do nothing, we pass the value, or we are multiplying it. So what do we mean by multiply? Multiplying nums to the numerator. Okay, and then we will get the HCF and num by is equal to HCF. This is just to avoid the redundancy or to reduce it into its simplest form. Okay, this is just for that reason. And then we can pass the fun, okay, the function, or we can divide it, that is denominator into nums of I, and then we can pass the function. Okay, the same thing we do over here also in fun1 also. Okay, this part is constant, but the map part is a little bit tricky if you want to understand it. See, once we are done with all the permutation till n, now we are going to do what? We are going to make, if map dot contains key num, that means we are going to store num and den, right? So if I find that num has already been stored, see, I told you how the structure is like. Num, one map pointing to another map pointing to a value. So how we are going to do the query? In this we put the num, in this we put the den, then we get the value. There is a count of how many pairs are having that. Okay. So if num is not having, let's say if num is having, okay, first of all, let's say if map has one num, the first map has num, then we are going to check in the second map, that is map.getNum, that if it has den or not. If it has den also, then it's very easy. Then we are going to put in the map, we are going to put den, 10 plus 1, map.get 10 plus 1, because it is going to increase the count by 1. Okay. Otherwise, we are going to put a new map, okay, where den and 1 is there. Okay. Now the whole thing is like, if map.put, so we are going to put into the map the MP map, okay? Otherwise, we are going to create a new map because there is no map over there. In that map, we are going to put den comma 1 because since there was no numerator over there, why would we even find that whether there was a denominator or not, right? So we don't need to find that also. We can simply say that map.put den comma 1 and map.put num comma mp. Okay, that's it. That's very simple. Okay, nothing different. And then we can return. Okay, this I was doing because I was checking if I was doing from 0 to n, if my answer is coming right or not. Okay, so now we have this. Now in this, once we reach I greater than equal to n, we are going to check for need num and need den, right? I told you need num is nothing but k into current den, and need den is nothing but current num. HCF1 is equal to GCD of need num and need den. Need num by is equal to HCF1, need den is by is equal to HCF1. Okay, so now we need this numerator and we need this denominator, so we have to find whether that pair exists or not. Okay, if map dot contains need num, okay, it has contains. If that need num contains need den, that means there is a pair, there is minimum one pair. Okay, then answer plus is equal to map dot get need num need den, and we get the answer. Okay, and obviously we return. This return is not inside the if. Okay, just for your information, this return is outside if. I don't know why this got formatted like this. This is over here. Okay, I don't think there would be any issues with this question. Then everything seems to be fine. Okay, great. Since not much attendance we got today, so we will be wrapping up the session real quick with the rating of the problems. La, 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 la. So that is it. That is it. Easy, medium, hard. The first question was rated as medium, I saw. I don't know why. It was an easy question, man. First question was an easy question. I don't know why they rated it as medium. The second question was digital public. So yeah, you needed to write a lot of things. So yeah, a little bit on this side of medium. Okay. Then there was a maximum bitwise. Same thing, man. Same thing. But since it is like yeah, it will be over here. And the D was rated as a hard question, but I found that D was a kind of stupid. Like obviously, I think there must be something more optimized, which I may not have come up during the contest. So there must be something more optimized which will make it a good question. But otherwise, I find it that it was a very stupid question. It may come up over here, okay? If I find out that okay, there is something really great logic behind this, and I really hope that it becomes a good question. Okay, because C was such a good question. Okay, C was a very good question. B was a okay question. A was also okay question. Like C, I enjoy doing okay because it's going to like test your bitwise manipulation skills. So yeah, that's it. Count sequence K. We are done with it. We are done with today's contest. Congratulations to me, to you, to everyone. There were a lot of AKs I saw. I saw there were a lot of AKs. There were 4469 AK. Damn man, people are upskilling themselves. Like even I'm not going to tell anything. Okay, so it's good that people are getting upskilled. That's great. People are so upskilled that they are not even coming to my live stream, huh? Just kidding, man. Just kidding. So, anyways, guys who are new to this channel, just to subscribe my channel and leave a like on this video so that I know that you came to this video. Um, if you want to support me, you can do very simple thing. You don't need to pay anything. You don't need to do anything. Just share my video with your friends out there who are interested in lead code post contests, even the code forces and code chef. Though, yeah, these days I don't do code chef that much. Code forces I still do, but since code forces is a little bit on the harder end, and it's there are a lot of questions, so I don't get that much of time to come live and explain all those questions. So yeah, that's it. That's it from my side. Thank you. Thank you, guys. Bye.